Welcome to the Walton Pi. Today we're going to be talking about the mean value theorem. So the main idea of the mean value theorem is that if we have a continuous and differentiable function on some closed interval, then there's going to be a point inside the interval where the slope of the tangent line to the function at that point that we're looking at is the same as the slope connecting the endpoints. Now that's a little hard to digest all at once, so we're going to break it down a little bit. So let's look at the following function on the closed interval, because we have solid endpoints at both ends. What we can do is the mean value theorem is going to be able to tell us something about this function. So if we look at the slope of the line that connects the two endpoints, then we can try and look to see are there any points in between those two endpoints where the tangent line is parallel to this line. Well, there's one there, there's another one there, and there's a third one there. So in this particular example, there are 3 points where the slope of the tangent line is the same as the slope of the line that connects the two endpoints. So these are points which demonstrate the mean value theorem and how we can be able to visualize what the mean value theorem means. So the statement of the mean value theorem is that if we have a function f of x which is continuous on the closed interval from a to b, and is differentiable on the open interval from a to b, then the mean value theorem tells us then there is a point C where a is less than c, which is less than b, so c is somewhere between a and b, where f prime of c, so the derivative of f evaluated at c, is equal to f of b minus f of a over b minus a. In other words, the slope connecting the two endpoints. So in our example, we had 3 different points where the slope of the tangent line was the same as the slope of the line segment that connects the two endpoints. The mean value theorem only guarantees that 1 exists. It doesn't tell us that there's 1 or 2 or 20. It doesn't tell us how many. It just tells us that there is at least 1. But on the other hand, it also doesn't tell us there can't be more than 1. All it does is it guarantees that there is at least 1 point where the tangent line is parallel to the line connecting the endpoints. Often when we are learning about the mean value theorem in a calculus class, it is preceded by Rolle's theorem. So Rolle's theorem says that if f of x is continuous on a to b and is differentiable on a to b, and f of a is equal to f of b, then there is a point C where the derivative at c is equal to 0. So the reason that we are often given it this way is that most books use Rolle's theorem to prove the mean value theorem. And also Rolle's theorem was published before our current version of the mean value theorem. However, there was an Indian mathematician whose name was Parameshvara Nambudiri who used a mean value theorem, or a version of it, about 200 years before Michel Rolle published his theorem in 1691. So for that reason, as well as the fact that Rolle's theorem is basically just an application of the mean value theorem, we can just jump straight to the mean value theorem. So it's usually easiest to just remember that Rolle's theorem is just an application of the mean value theorem. In other words, it's the mean value theorem where the slope between the two endpoints is just 0. And if you're trying to remember what the difference between Rolle's theorem and the mean value theorem is, a mnemonic that I use is that a rolling pin makes everything flat, and so Rolle's theorem is when the line connecting the endpoints is flat. So that's the way that I am able to remember it. So let's go into a couple examples now. So let's say we are asked to determine, is there a point in the interval -2 to 4 where the tangent line to y equals 4x squared minus 7x, where the slope of the tangent line is 1. So let's go through and see if we can use the mean value theorem to figure this out. So since the endpoints of the interval are going to give us the point -230 and 436, the slope of the line connecting those 2 points is going to be 1, because over a run of 6, it rows 6 as well. And so because the slope of the line connecting the two endpoints is 1, and since 4x squared minus 7x is continuous and differentiable everywhere, that means that the mean value theorem tells us that there is such a point. And we'd be able to do a little bit of work and be able to show that this point happens at x equals 1. Let's go through another example. Is there a point in the interval -1 to 1 where the tangent line to y equals x to the minus 1 has a slope of 1? Well, if we check the endpoints, f of negative 1 is negative 1 and f of 1 is 1, so that means the slope connecting the two endpoints would be 1. So we might want to say, yeah, sure, there's going to be a point where the tangent line slope is 1. However, y equals x to the minus 1 is discontinuous at 0. So because it's not continuous from negative 1 to 1, the mean value theorem does not apply. And so it does not guarantee that there is a point where the slope of the tangent line is 1. And it turns out there isn't a point where the slope of the tangent line is 1. Let's go through another example. Is there a point on the interval negative 3 to 1 where the tangent line to y equals the absolute value of x has a slope of negative 1/2? Well, if we check the endpoint, the line that connects the two endpoints does have a slope of negative 1/2. So we might want to say, yeah, there's going to be a point where the slope of the tangent line is negative 1/2. However, this function, while it is continuous, is not differentiable at 0. So because it's not differentiable everywhere in the interval, that means that the mean value theorem does not apply. And let's do one more example of how we might be able to use this in a way that doesn't look directly like it's going to be a mean value theorem problem. Let's say we are asked to show, is there a point in the interval 0 to 5 where the tangent line to y equals x cubed minus 2 is parallel to the tangent line to y equals 4x squared plus 5x plus 6? Well, the mean value theorem only applies if we have a single function and we connect the endpoints. So let's define a function, f of x, to be our first function minus our second function. So f of x is x cubed minus 2 minus the quantity 4x squared plus 5x plus 6 end quantity. So f of x is x cubed minus 4x squared minus 5x minus 8. And so now we can look at f of 0 is negative 8 and f of 5 is also negative 8. So that means we can use Rolle's theorem to state that there is some point c in the interval 0 to 5 where f prime of c is equal to 0. So that means that there is somewhere where the slope is going to be the same, because at that point c, the tangent line of y equals x cubed minus 2 and of y equals 4x squared plus 5x plus 6 had to have been the same. We don't know what the slope is, but we do know that it exists and that the two slopes are going to be the same. I hope this video was helpful in understanding the mean value theorem and Rolle's theorem. Please check out some of my other videos if you found it helpful, and please like and subscribe so that I can continue to make these videos. Have a great day and good luck with the rest of your math.